Graph Theory Class 4 Video 3. In this video we're going to talk about a process called Eulerization. Eulerization is the process of taking a non-Eulerian graph and making it Eulerian. I will say that from now on, for this video, we're just going to focus on undirected graphs. Okay, so we're not going to worry about Eulerizing directed graphs. So let's just begin with a definition. So Eulerization is the process of taking a non-Eulerian graph and making it Eulerian by adding duplicate edges. Okay, so this is a very important part of the definition. Also, I want to really emphasize this part here, duplicate edges. You're not allowed to add a new edge where there wasn't an edge before. You have to only add duplicate edges. Okay, and the general process would go something like this. The first step is to pair up all the odd degree vertices. Okay, if I give you a graph which is not Eulerian, that means, using the theorem we saw in a previous lecture, that means that there are some vertices that have odd degree. So the first thing I want you to do is to work out all the odd degree vertices and then pair them up in some way. The second step is to choose paths between the pairs. Choose paths between the pairs. Okay, and then the third step is just to add duplicate edges to all the edges along your paths. Okay, this is the general process for Eulerizing a graph. Okay, you find all the odd degree vertices, you pair them up, and then you choose paths between the pairs, and then you duplicate the edges. So one thing I want to mention is it's usually preferable to Eulerize with as few edges as possible. So you usually want to duplicate as few edges as possible. Okay, because you may have noticed this three-step process I gave you, it's not 100% deterministic. It depends on some choices which you make. I mean, for step 1, I say pair up all the odd degree vertices. But if you have 4 vertices with odd degree, then there's more than one way of pairing them up, right? If vertices A, B, C, and D are all odd, then you could pair up A and B and C and D, or you could pair up A and C and B and D, or so on and so on. For step 2, it says choose a path between the pairs of vertices. Well, what happens if there's more than one path that you could possibly choose? Maybe some paths are longer than other paths, so you want to make sure that you choose the shortest path. Okay, so there's choice involved in these steps, and it's usually preferable that you duplicate as few edges as possible. So let's do an example. Okay, Eulerize this following graph with as few edges as possible. That's what I want to do. So how can I do this? Well, let's begin by calculating the degrees of all the vertices. Okay, so let's calculate the degrees of all the vertices. This is degree 1, this has degree 5, 2, 3, 3. So I have a bunch of odd degree vertices. All of these are odd degree. Okay, so that means I want to pair them up. So I'm going to pair up this vertex with this vertex, and I'm going to pair up this vertex with this vertex. Okay, now I'm going to choose a path between them and duplicate all the edges along that path. Well, For the pink vertices, there's only really one choice, right? So I'm going to duplicate this edge here. I duplicated the edge between the two pink vertices. For the yellow vertices, I sort of have two choices of which edge to duplicate, right? It doesn't matter too much indicating which one I chose. I just do this. I add an extra edge here. Okay. And now, if I work out the new degrees, you'll see that all of the numbers are now even. So, including the pink and the yellow edge, the graph is now Eulerian. So I've Eulerized this graph by adding duplicate edges. Okay. And I've done it with as few possible edges. I've done it by adding 2 edges. I couldn't possibly add fewer than 2 because I had 2 pairs of odd degree vertices. So I needed to add at least 2 edges. Let's do another example. Okay. Let's look at this example right here. So the first thing I'm going to do is calculate the degrees of all the vertices. So 1, 4, 2, 4, 1, 2, 2. So I have 2 odd degree vertices, 1 and 1, on either end of this thing. Okay, so now I have to choose a path between these 2 vertices. And I have choice, right? I could choose that path, or I could choose that path, or I could choose that path. But the question explicitly asks you to Eulerize with as few edges as possible. So I want to choose the shortest path, which I think is just this path right here. Okay, this path right here only uses 3 edges. So I'm going to duplicate all the edges along this path, like that. Okay, and I draw them in dashed lines so you know what I've done, but it's acceptable for you to draw them in solid lines as well. I've duplicated this edge and this edge and this edge. Okay, and that's, if we now work out the new degrees, this is degree 2, this is degree 1, 2, 3, 4, 5, 6, this is degree 6, and this is degree 2. So now everything has an even degree, which means that the graph is Eulerian, and we've successfully Eulerized the graph. Okay, that's the end of this example, and that's the end of this video.